convolution and LTA system. You see, this is the thing for any system, right? So any system X of n you will have a transfer function and you will have Y of n. X of Y of n is called as the output and X of n is called as the input signal. Okay? And the system will have an impulse response given by H of n. H of n is going to be the impulse response. Okay? So now we are going to see if the input to the signal is a sinc function, what is the output Y of n? See here, input signal is given x is equal to sinc of n. So if I am going to give input as a sinc function, what is the output? See here, the input is a sinc function and the output is going to be like this. And what output I have taken, I am considering the system to be a moving average. Average means it will take average of the values from the current sample to the 3000 point. So it will take the average and plot the signal. So the signals will be more or less looking same because I'm taking the average. And impulse response, it is going to be the unit impulse signal. Impulse signal will exist only at 0, right? So it is going to be at the exactly at the 0, and the value is going to be. So if the signal is sinc of n, I get the answer. Now instead of sinc, if I give sine, will the answer be same or different? Let's see if I give sine of n. You can see the sine wave here getting changed. Able to understand? So you can give different inputs and see what is the output. And output is an average function, so it will be closely looking like your sine wave only. And unit impulse signal is here, and output is going to be H of n. This is a simple LTI system. You know what is meant by LTI? LTI means linear time invariant system. So it obeys the properties of linearity and time invariance. Linearity means when you add two signals, when you add two inputs and give to the system, the output will also have addition of. Time invariant means if you change time, the signal system is invariant to time. I get bus at 8 o'clock, I reach my college at 9 o'clock. I get bus at 8:15, I reach my college at 9:15. My traveling time is going to be always 1 hour. That is a time invariant system. For example, on weekdays, I get my bus at 8 o'clock, I reach my college at 9 o'clock. In Saturday, I get my bus at 8 o'clock, I reach my college at 8:45. The duration of travel is getting changed, right? So that is going to be time variant system. Okay, so LTI means we'll assume all system to be linear time invariant system only. Okay, so that is assumption, but actually in practice, all systems are linear time variant. Since there is no model available to quantify this linear time variant system, we'll assume all linear time variant system to be invariant and we'll approximate the model. So we have seen how a simple change to means try with cos. See how the input output is getting changed. You can see the signal. This is how a signal is visualized using MATLAB. Input, output, impulse response, and output H of n. So now see here. Find the K average. So you can find the K point moving average by you giving the formula here. See here, the answer is given here. We'll try this, substitute this here. And we'll run the section to see what is the H of n. H of n is going to be a rectangular pulse. H of n is going to be a rectangular pulse from minus 1 to 1. This is when you are doing the n-point average of the signal. We have considered the 3000 point average, right? So when you do the average using time domain, this is going to be the impulse output H of n of the system. See here, we got X of n, we got Y of n, we got the impulse signal, and we got the H of n, the moving average